Hello, science people. Lemons. What do? They are sour. They could combust. They prevent my guacamole from going brown. Limes. What do? They are in my guacamole. Well, when life gives you lemons, suck the citric acid out of their souls. So what can we do with this sour powder? We can make mozzarella, make sherbet, remove rust from metals. These guys have the idea. So, which citrus fruit will give the most citric acid? I'd like to state before we get started that there is a copy of my information in the description below, so if you get lost, you can have a look down there. In this experiment, I will be looking at the citric acid I can extract from lemons and limes, and comparing the two. I believe that the lime will have less citric acid than the lemon. Now here is a really long boring list of all the equipment needed. I'm not gonna say it, but you can pause the screen and read it if you really would like. And here is also a really long boring list of my method, pretty much just stating what I'm going to do. But I'm not going to read that out because I will be saying that throughout the video. So again, if you want to read it, please pause the video. Now, before we start the experiment, it's good to know what safety precautions we'll need to take when handling these chemicals. When handling sulfuric acid, sodium hydroxide, and calcium chloride, be careful not to ingest them as they can cause internal burns and irreversible organ damage. They are very corrosive and can cause permanent blindness if in direct contact with eyes. Make sure to wash skin or eyes immediately, and if ingested, do not induce vomiting and rinse mouth. Seek medical attention immediately. Make sure to wear appropriate clothing and safety glasses, and make sure to wear leather shoes and be aware of your surroundings and where the chemicals are. Seek teacher's help if anything goes wrong. Now I did some research and it says that 1 teaspoon of powdered citric acid, which is about 4 to 4.2 grams, is equivalent to a quarter cup of lemon juice, 59 mils. And it also states that each ounce of lemon juice, which is 29.5 mils, has about 1.5 grams of citric acid. I estimated about 10.98 grams of citric acid for the lemon juice and 10.58 grams for the lime juice. So I got to work and I juiced 100 lemons and limes. Jokes? Do you think I actually had the time or willpower to sit there and do that? I just bought a squeezy bottle. This is what the juices look like. Lime is on the right and lemon is on the left. And I added the 10% sodium hydroxide solution in both until it turned into the forbidden orange juice that you can see here. And no, you cannot drink it. I ended up making 2 lots of the solution as there wasn't enough for the pH change or the color change. But I only ended up using about 60% of the second one. It was then strained to get any precipitates and pulpy pulp out of the solution. I wouldn't recommend smelling it as it smells like really bad urine after someone has eaten a lot of asparagus. Also because it's a bunch of chemicals that shouldn't be inhaled. I then created a calcium chloride solution and halved it to pour into each solution of juice. The juice looked like a really milky texture that started to go off and separate. At this point it smelled really good and I really was tempted to drink it. But of course do not ingest any of these chemicals. It smelled like honey lemon tea. Oh, so good. What's weird is the lime juice looked more like lemon juice than the lemon juice. I boiled the liquid and it looked like it was dancing around in the mixture as it separated. The heat made the precipitates move up and down. Those molecules are having a little dance party and I'm not paying for the cleanup. It was very audibly popping, so much that we could visibly see it moving. So we had to stop boiling it for safety reasons. It seemed to still be alright as we did bring the reaction to a boil. One of the errors that I believed I caused was when the calcium chloride solution was added to the mixture and boiled. I believe I could have left the mixture to boil some more to speed up the reaction, but to be safe, I turned it off because it was visibly jumping and popping and I did not want the beaker to explode. I left the mixture filter over 2 days. After the 2 days, the mixtures looked a bit like this. The lemon one was still a bit wet, and the lime powder was very talcum powderish, but I doubt you would want to put this on a baby's bum. I made a mixture of 20 ml of sulfuric acid and 200 ml of water. I then halved the mixture and added it to the weird wet talcum powdery mixtures. After I added the sulfuric acid mixture or solution to each of the beakers, I halved it. I then filtered it to get any precipitates out and threw away the filter paper filled with excess particles, matter. I then boiled the 2 separate mixtures of lemon and lime juice that are now had sulfuric acid added to it. I boiled it, and I thought I was doing something wrong, but it was actually another classmate that was trying to gas us all with sulfuric acid, because I started getting dizzy and headache, like I was gonna faint. I thought that was me, but no, Zamar, you know who you are, trying to gas us all. Anyway, I boiled the mixtures until each of the mixtures were about the same. I think the lime juice was at 25 ml and it started at 75. And lemon juice was at 100 ml and it got down to about 50, so they both about halved in size. After they had boiled down to roughly about the same, I then poured each mixture into separate petri dishes, all labeled with a marker, LI for lime and LE for lemon. I only needed to use about 4 petri dishes. I left the mixtures to then evaporate for about a week. There was a thick viscous liquid left in the petri dishes. I ended up putting it in a fume cupboard to put it in a evaporating basin and put it on a hot plate. That didn't really work out. It smelled like burnt sugar and burnt lemons, and overall just didn't work out. Luckily I took some measurements and recordings beforehand. These are some of the tables that I have made. This one is showing how much lemon juice and citric acid I got. This one is showing how much citric acid I got from the lime juice, and then this one is comparing them to. I calculated the return percentage of citric acid. I got for lemon juice 102%, and for the lime juice I got 49.4%. The lemon juice, I don't know how I got over the amount. In these graphs I can see that there is no trend. For validity, I definitely was testing citric acid. There was no way that I could test the citric acid. The investigation is reliable if I did it multiple times. I believe I just didn't do it correctly. Possible improvements: I could use actual lemon and lime juice instead of the bottled variants, as I believe I would have gotten a more accurate result and clearer crystals. I could have also let the mixture evaporate more, and instead of trying to force it by boiling it. In conclusion, my hypothesis, limes will have less citric acid than lemons, is accepted and shown in the data. If I could do it again, I would have done it differently, I reckon. To make this clear, my independent variables were the lemon and lime juice. The dependent variables was the amount of citric acid given from the juices, and the control was the same volume of juice as well as the same times in the same areas. Thank you for listening to my experiment and how it went. Here is my bibliography.